Software Engineering Radio, Episode 1, Patterns. Welcome to this first official episode of Software Engineering Radio. In this episode, Markus Völter and Michael Kirchhoff talk about patterns. Patterns are a very important topic in software engineering. It's become widely known through the Goff book, Design Patterns. However, in this episode, we also talk about patterns that go beyond what the Goff book describes.
What are the top three examples you could give on patterns?
I think the most used and most well-known pattern is probably the observer pattern, where one object notifies a set of other objects of changes. So, for example, if you have some graphical application where several views have to reflect the changes of some data structure, then whenever the data structure changes, the data structure notifies the various view objects of the change, and they can then query the change data and then change the view accordingly. Another well-known pattern is probably the proxy. It's used all over the place in remoting systems. So instead of talking to an object directly, which you obviously can't do if it's located on a remote machine, you talk to a local object that looks the same as the remote one, and the local one, the proxy, forwards all the calls to the remote one through networking or other means. And another one is the reactor, which I think it's better if you explain, Michael.
Yeah, the reactor basically decouples the demultiplexing and dispatching of events, for example, network events, from the application-specific logic to handle events. So you have the reactor on the one side, and you have application-specific handlers that you register with the reactor, and whenever the registered event occurs, the handler is invoked and reacts on it.
So it's mainly used for building scalable multi-threaded systems, or?
Yeah, not actually multi-threaded. Reactor actually can serve well to design single-threaded applications, single-threaded scalable applications, and but you can also work with it in a multi-threaded environment, but then you also need other patterns like the leader-follower pattern to cope with the concurrency.
Okay, so before we go into too much detail, I think we'll explain one or two patterns in detail later. Maybe we should talk a little bit about the history of patterns. When did it all start? I thought like Walt Cunningham was the first person to talk about it.
Yeah, Walt Cunningham and Ken Beck, they started in 1987 with the documentation of, I believe it were 5 user interface patterns that they documented at c2.com, and with that it all began. They started to do publications about it, and in the 1990s Ken Beck actually wrote his dissertation. In the 1990s, Erich Gamma wrote his dissertation on patterns, which then later resulted in 1995 in the well-known Design Patterns book by Erich Gamma, Richard Helm, Ralph Johnson, and John Vasilis, the Goff Gang of 4.
It's funny because I think most people think that the Goff book was actually the first patterns thing in the IT world, but that wasn't actually the case.
Yeah. Soon after Goff, then the pattern-oriented software architecture track started by Bushman, Stahl, Meunier, and Ronot started. It's mostly referred simply as POSA 1.
Okay. And is there a difference between the patterns in the Goff book and in the POSA book? I mean, the Goff patterns are known as the classical design patterns. What's the content of the POSA 1 book?
POSA 1 book is more about architecture patterns, sometimes also referred to as architectural styles.
Okay. So before we discuss more about the content of certain specific patterns, I think we should look a little bit at the form of patterns. So patterns are documented in a very specific way. Actually, there are several ways. If you look at the Goff book, the original design patterns book by Gamma and the others, they basically have, I think it's 11 sections for each pattern, right? Like
Yeah,
11 subheadings.
I believe so.
Yeah. And the most important ones are certainly the context, the problem, and the solution. So if you want to define what a pattern is, people say a pattern is a problem in a certain context with a specific solution, and that problem is usually well known. So documenting a pattern only makes sense if the problem that it solves is actually encountered by many people in different solutions and in maybe even different technical contexts. So the context section of a pattern describes the environment, the situation in which you typically are software-wise when the problem arises, that you then describe as the second part. And then, of course, you show the solution that helps you solve the problem in that specific context. Another important section is the forces. You can only solve a problem in a specific way if you know what you have to take into account when solving it. Like for example, the system should run fast, or it should consume only as little memory as possible, or things like that. So when describing the problem in the pattern, you always have to add a number of forces that guide you when finding out the solution. And this basically comes down to a kind of reusable piece of knowledge that other people can read or listen to and then use in their own environments, in their own software.
Markus, in this context, I often heard also the term resulting context. So what exactly is the resulting context of a pattern?
Yeah, so if you describe the solution of a pattern and this solution solves the problem taking into account the forces in a specific way, then after you implement it or you decided for a specific solution, then you have consequences. You know that, okay, so solving this problem this or that way makes the system quite fast or slow or small or scalable or whatever. And once you are there, you can then describe kind of new problems that arise from having used that pattern, and that basically opens the road to several other patterns that might follow the current one, follow in the sense of if you have implemented this one, then you might want to consider also implementing other ones, because the resulting context recommends using other patterns. So this is especially interesting in pattern languages and pattern sequences. I think we discussed that later.
Okay, and then I also learned there's the Alexandrian form, there's the Goff form, Pausa has its own form, then there's the Portland form.
Yeah.
So what is the key difference between those forms, and why are there multiple forms?
Okay, so I think the community agrees that a pattern is always, as I said before, this problem in a specific context with a well-working solution. However, there are different kinds of patterns, we'll see that later, and different kinds of patterns can be described in different literal forms better. So for example, if you have a very technical pattern, software design, then the Goff form is probably very useful, because it also includes sections such as structure, where you then usually add a class diagram or something like that. You have a section interactions, where you use sequence diagrams or something like that to show how the dynamic collaboration between the various participants of the pattern is actually set up, and so on. However, if you, for example, describe, organizational patterns, we'll talk about that in a couple of minutes, then these organizational patterns can't be described necessarily with those technical terms and diagrams and structure and interaction. So there are other pattern forms that are more useful for this kind of pattern. So if we talk about the Alexandrian form, this is interesting because it's the original form used by somebody called Christopher Alexander. He is a building architect, so nothing with software. And so he originally invented the form of using patterns to describe stuff. He wrote a book called A Pattern Language, which contains, I think, 253, not sure, patterns organized into a pattern language that help people design good cities and good buildings and good living rooms and these kinds of things. And he used a specific form. It had very little structure, so it didn't have these 11 subheadings. It was more like 4 or 5 sections. So it was context, problem with forces, solution, resulting context, and then an example, if I remember it correctly. And so this is a good form that can be used if you describe non-technical things. Although you can also describe technical things, like we used it in our book for describing remoting infrastructures. So the Goff form, Goff stands for Gang of Four, basically starts with a heading and then a small section, maybe 1 or 2 sentences that abstracts the purpose of the pattern. Then we go on explaining the motivation. That's typically an example situation in which you want to use the pattern. Then the next section is the so-called applicability, where in general terms in which situation the pattern is useful. And then the funny thing is there is actually no real solution part. It doesn't say solution anywhere. It just goes on and explains the structure of the solution. Then it explains the various participants. For example, in the context of the observer, you have the subject, the thing that changes, and the observers, those that want to be notified about the change of the subject. Then you have the interactions, which look at the structure from a more dynamic point of view and show how the various participants interact. Consequences, and then an important section, especially for low-level design or coding patterns, implementation. You can usually implement a pattern in various ways. Things change or vary in detail, and the implementation section shows you step by step how to implement a pattern, and also if there are variations in implementations, shows them. The next section is then even more example code. This usually connects to the introductory motivation. And then, very important in all pattern descriptions is known uses. A pattern is not something you invent, it's something you dig out from existing systems. So in order to kind of prove that what you describe is actually a well-known and well-used solution for the problem, you will list and explain known uses. And then finally, the Goff pattern form finishes with a number of related patterns to kind of give you a roadmap through the books or collections of patterns. So, Michael, why don't you explain a bit more about the POSA form?
The POSA form is another form. It has been used in the past 3 POSA volumes, and so I'm more closely related to the POSA books. So, and maybe because of that, I like the POSA form more. The POSA form has an explicit solution section, and it explicitly marks and lists the forces, which I think is very valuable to know what kind of trade-offs the pattern is suggesting, what kind of trade-offs I have to consider. And also it has an explicit variance section where certain variations from the core of the pattern are documented, and so instead of just having then a separate pattern for it, you can cover the variance in the variance section. Besides that, there's much in common. The intent is the context here in the POSA form. That's it.
So maybe then let's move on to discuss some of the misconceptions about patterns. I think there are a couple that it's worth pointing out. Do you want to start with the blueprint thing?
Yeah, very often I hear that patterns are regarded as UML blueprints, as that the pattern always has to have the same implementation class structure in OO, and that patterns are only about object orientation. And that's not true. You can apply patterns also to other systems and also to non-object oriented ways of solving, ways of programming, even though it best matches with object orientation. So yeah, in some case tools, computer-aided software engineering, or today it's called model-driven software development tools, it's also called blueprints, and that there are patterns, but you have to be careful with that. I let you iterate on it, Markus.
Yeah, because this is really something where I have a really explicit opinion about. So, you know, in those model-driven tools, they're usually talking about automatically implementing patterns, and this is to some extent kind of nonsense. On the one hand, of course, if you decided that you want to use a certain pattern in a certain situation, then you can let your generator, your code generator, your case tool, your MDA tool, your whatever, you can make sure that the tool actually generates the respective code to implement the pattern in the code it generates. However, reducing patterns to something that's automated in such tools is probably really a bad idea, because patterns are basically documentation. They have a lot of aspects, several aspects that cannot be automated. Things like the forces. I mean, the decision that guides you through whether it's useful to use the pattern and which variant and why and how is not something you can easily automate in tools. It's probably a good thing to keep the term pattern separate from automating certain code transformations in tools. They're probably better called templates. Of course, if you have templates that implement the observer pattern, then it's useful to say that your code generator uses the observer pattern internally. But saying that the patterns are basically automated through the tool, you don't have to understand the patterns, just use the tool. That's nonsense.
Yeah, another common misconception is that patterns are innovations, and that's really, they are the opposite. Patterns are best practices. Patterns have to multiple known uses of existing systems, so having known uses means I'm not innovative anymore, but still they are very valuable for documenting and communicating best practices. And for example, for new problem domain, for example, for aspect-oriented software development, you just have then to start mine patterns from experience. From scratch, there are no patterns, and people who would claim that, I typically don't believe. It has to ripe the domain. People have to learn, they have to have experience, and then they would together derive patterns from it.
So this probably means that most patterns are not written by university personnel and researchers who have to write papers about new things, but rather patterns are probably written by practitioners and folks from industry, right?
Right.
Okay, which is good for a change. So maybe let's look at some of the domains that are covered with patterns. I think most people know the Goff book, so it's basically, most people know design patterns, patterns that help you make your object-oriented designs better. So, but I think we agree that it's not, I mean, this is the bare minimum that people have to know about patterns, and I think everybody really knows them. But maybe let's talk about some more not so well-known domains in which patterns have been used. Do you want to start?
Yeah, well, the closest one is the domain of software architecture, and POSA 1 is definitely one of the examples in that area. But there's also like user interface design, user interaction patterns, testing patterns, for example, those by Manfred Lange and Kyle Brown. There are teaching patterns. Markus, could you explain something about those?
Yeah, the idea was to collect best practices and patterns in the context of teaching. So describing how to efficiently design courseware, how to run classes, and so on. And there has been a big community called the Pedagogical Patterns Project. Recently, it hasn't been very active, but there are very interesting patterns written in this area. So if you're a person who works with teaching and designs classes, it's really worth looking at it. There should be a website called the www Pedagogical Patterns Project. Not sure whether it's still online, but certainly worth a try. Also at my own homepage at völter.de you can find some pedagogical patterns and links to other ones.
Cool. So the next area is like documentation. There's the Agile Documentation Patterns book by Andreas Rüpping. There's the organizational whole area lately covered by James Coplin and Neil Harrison, and also Linda Rising. They had a book on it. I believe the title was Fearless Change. Definitely worth reading, and you can learn a lot from it.
There is also patterns or books that describe pattern languages for various middleware and infrastructure things like remoting and components, but I think we'll discuss those aspects in later episodes, so we won't go into detail here, right?
Right.
I think something we should talk about is the way how patterns come about, and since patterns are, yeah, as we said before, mined from the experience of a community, there is also a very well-working community that helps pattern authors to refine them. So maybe let's talk a couple of minutes about the Plop conference series and how those conferences work. I think that's fun.
Yeah. So Plop stands for Pattern Languages of Programming, and they got initiated in the early 1990s. I believe 1994 was the first one. And yeah, those conferences have a very typical form. They're their own form of running the conferences, and the key events at those conferences are the writers' workshops. And Markus, could you explain what a writer's workshop is?
Yeah, so the idea in Patterns conferences is not that people come there and present their work to a audience that sits there and listens and looks at the guru presenting stuff. Rather, the Patterns conferences are authors conferences. So authors go there to present their work, yes, but then get feedback. So the first step in those conferences is what is called shepherding. So you submit your paper, and then you're assigned an experienced patterns author who gives you very, very, very detailed feedback on the pattern. This is a process that goes about 2 months or something, usually 2 to 4 iterations, and as a result, your pattern should be much better from a content perspective, but also from a structure and language perspective than your original submission. So the next step then is you go to the conference, everybody meets, has a lot of fun, and in the writers' workshops there is usually a group of maybe 6 to 12 people who basically sit in a circle usually. You, as the author, don't say much. You sit there, listen to the discussion of your colleagues who discuss your pattern. So they talk about what they like in the pattern, and so you're kind of confirmed that certain things have been a good idea. They also tell you what should be improved in the pattern. So after usually about half an hour of listening to them, you should get a lot of additional inspiration of how to improve your pattern. So as a consequence, after patterns have gone through such a writer's workshop, they're usually much better, at least from a readability perspective, than the original submission, and this helps to keep the quality of patterns publications up.
Okay, and the original Blob conference is the one in the United States, in Illinois. That's the Plop conference, but there are also variations and derivations in Europe, for example in Germany and Scandinavia, and also in South Africa, not to list all the Plop conferences.
So it's probably worth pointing out that if you're interested in patterns a bit deeper than kind of just using the design patterns, then it's probably a good starting point to go to one of those conferences, even if you don't have a paper, because it helps you get in touch with the community and all the process and all these kinds of things. Although, of course, it's more fun to go there if you have a paper.
A good link to check out is hillside.net. The Hillside Group is basically the common basis of the pattern community, where you find all the information and follow-on links about the community, the patterns, books that have been written, just almost everything about patterns.
Okay, so we've talked about patterns a long time now in this episode. Previously, I think we mentioned the term pattern language. I think we should explore a little bit what kind of other kinds of pattern-like literature there exists. You want to start?
Yeah, so POSA 1 actually started with the term system of patterns, and that is patterns that have a loose relation to each other, which is basically, a catalog is also sometimes a term used for it. A catalog of patterns which has no tight connection to it. Then there is the term pattern compound, for example, the bureaucracy pattern by Dirk Riele, and compound patterns contain other patterns.
So they're creative combinations, or
they're kind of well, at one point it was a creative step, yeah, but then they use, for example, in the case of bureaucracy, they use the composite, mediator, chain of responsibility, and observer pattern internally to achieve their solution, their goal.
So, cynical question: you take a number of existing patterns, combine them, and give it a new name? Or?
No, it's not like that, and you wouldn't get through a writer's workshop with that. You must provide additional value. It must be a meaningful and new combination of patterns that's not just an addition of existing patterns, but there's a fine limit, a fine border between what's really then acceptable as a compound pattern and what's not.
Okay. So the next kind of step upwards in complexity is the pattern sequences?
Yeah, pattern sequences are a topic that is still maturing. A pattern sequence describes basically how a system evolved. What was the first pattern that got used? Then the second pattern. It's really a stepwise refinement of and development of your architecture. And a pattern sequence is basically one useful stepwise refinement using patterns to build a system.
Okay, and the most elaborate way of combining patterns is probably the pattern language?
Yeah, pattern languages combine several pattern sequences for a specific domain, for example, remoting. So in a domain like remoting, a pattern language documents all the most common, the most applicable patterns with trade-offs and alternatives. Whenever you selected one pattern, depending on the resulting context, on the consequences, you might choose another pattern, and the paths through the pattern language are described using pattern sequences.
So that means, I mean, to some extent it sounds quite esoteric and not very useful, but if you look at some of the books published in that area, they really give you a hands-on guide through potentially quite complex topics, like for example remoting. They start with explaining, things like proxy and marshalling, and then talk about how you manage the life cycle of those remote objects, talk about asynchronous communication, and so on and so on. So they're really very, very useful if you want to understand certain domains a bit deeper than just understanding the API of Corba or something like that. So I think this brings us to our next topic, which is basically the advantages of patterns. Why would you care? I mean, why are patterns important?
I think primarily patterns are a good idea because they allow you to better communicate software. Software is something that you can't touch, obviously, and so talking about the internal structure and the design reasonings has always been hard without patterns. With patterns,
yes,
we have a means, a common language basically, to talk about software, its structure, its design, and everything around it. The second thing is reuse. We share experience, we share best practices, and yeah, to a certain extent, evolved the field of software development. There's also the high goal of a software handbook, a software architecture handbook, several times tried, never really achieved yet, but hopefully
most current one is Grady Booch's approach, right?
Right. But hopefully we'll succeed as a community in the future, because I think something like that could be really valuable to really mature software development to an engineering domain, to make a bit more structure into it and to achieve the engineering aspect of software engineering.
Important, since we're software engineering radio.
Right. The other thing, I believe it really helped me structure my thoughts. It helped me structure the way I work, the way I act doing software development. So the strong focus on structure helped me also in writing good requirement specs, because I knew when I later have to design my system, I what I have to rely on, what I need to make good design decisions.
Yeah, so if you have read a lot of patterns and maybe even wrote some patterns, then you kind of naturally think in these chunks of knowledge called patterns, right? So if you have to explain things or write things down or build a system or whatever you have to do, you kind of naturally start thinking in patterns, and you think you have a problem, you think, oh, I've heard about a pattern that solves this problem somehow, and you open the book or surf to some web page and you read the details, and it really helps you, yeah, structure your everyday development work. I think that's really important. Another thing that I think is important is actually that writing patterns can help you understand things. So when I first read the Goff book a long time ago, this really helped me to kind of get beyond this, object orientation is about inheritance and encapsulation thing. So it kind of gave me the next step of building object-oriented systems based on the Goff book. And then when I started writing patterns, this actually was kind of the next step because it improved my writing style. So if I today write an article or any kind of documentation and I have enough time to actually do it right, then this always looks a bit like patterns. So I try to explain the context first and then outline the problem that I'm trying to describe or that I document or that I solve with a system that I just documented clearly, and then I come up with a solution. I explain what the consequences are, and I motivate all that with a easy to understand example. So writing patterns is not just useful, to get the ticket to Irsee to go to the Europlop conference. It really helps you improve your writing style, and that's something that many people should do.
Gosh.
Especially in the huh?
Gosh. Yeah. I said gosh.
Okay, so to explain, the term "gosh" is used in writers' workshops to express that you have exactly the same opinion. Instead of saying something again and again and again, you just say "gosh" to agree explicitly with what the other guy said. Okay, one thing before we kind of wrap up and point to some additional resources, I think it's really interesting to point out the amount of literature that has been created from the patterns community. 50 books? Is it 50 or?
Yeah, I just looked up at Hillside.net and it was like 50 to 70 books on patterns, about serious patterns books.
You mean serious in the sense that they have been workshopped and this kind
They
of
have been workshopped and they adhere to the rules of the community and not just claim their solutions to be patterns just because they named them patterns.
So especially a while ago, it was a good sales argument to put the term pattern on your book cover. But to me, it seems like the community is a bit, I don't know. If you haven't been to the conferences, you're not allowed to use the term pattern. It's probably a bit harsh, but to some extent, people expect that patterns in a book have been workshopped, at least partially, on one of those conferences, right?
Right. So the blob conferences are, so to say, our quality assurance in the community.
Right. So there's also kind of best of. So in addition to the proceedings which you can get from various sources, including usually web pages, there is also a series by Edison Wesley, which is called Plop, the Pattern Languages of Program Design series. 4 volumes have already been published. A 5th volume should have been published a while ago, but the publisher said it's in the kind of final stages of production now, whatever that means. So these Plop D books basically contain an even more refined selection of the patterns of the various conferences. So they're kind of best of.
Another good link, another good hint I want to give is the Pattern Almanac by Linda Rising. It's now from the year 2000, but still valid and a good start into what kind of patterns are available. And you can use the index in there to search for patterns that have been documented on the problem you currently face.
Is there a one-stop web page you should go to learn more about pattern? Is there, the web-based patterns catalog? I think it doesn't exist, does it?
No, it doesn't exist yet. As with the software architecture handbook, Many people strive to achieve that, but it's not yet there, though planned. I know that it's definitely planned, and whenever it will be out there, I'm sure you can find then the link on hillside.net.
Okay, so I think this concludes our discussion about patterns. This was another episode of Software Engineering Radio. For general information and past episodes, go to www.se-radio.net. SE Radio wants to thank Henning Pauli for providing the music we use in this show.